All right, so yesterday, Mr. Van Hood said you guys worked really hard. That's good. He's a pretty good judge of that because, well, he's even older than me. Makes him ancient. And he said you guys got to these practice ones, yes? Okay, how far did we get? Did you just get started on them? Okay, hadn't had a chance to go through any yet? All right. Why don't we go through the first couple here just to kind of refresh what we learned yesterday about the 5 different reaction types. Right? There are more than 5 types, obviously. We're only going to be concerned with kind of the 5 basic groups that reactions can fall into. Right? And those groups, remember, they can be a synthesis reaction. Or generally, 2 elements combined to form a single compound. Okay? It can also be 2 compounds combining to form another single compound, but it's generally 2 elements. Okay? And then we have its opposite, a decomposition reaction, where generally a single compound breaks down into its elements. But it can also be a single compound breaking down into smaller compounds, but generally it's going to be the 2 elements. Okay? And then we had combustion reactions, which had their own set of rules for balancing and for all of that kind of stuff. Okay? I can't remember if I chose the podcast where I did the Yoda voice. Oh, good. Okay, good. Because that was like kind of embarrassing later. But okay, so we got combustion reactions where we have the special rules. Okay, we have that we balance them alphabetically. Okay, and we have the rule of 2. Okay, where if you have an even number of carbons, you start balancing the reaction with 2. Right, and we'll go over that again here as well. And then we have the 2 types of replacement reactions. In a single replacement reaction, an element reacts with an ionic compound and replaces the part of the ionic compound that it is like. And then in a double replacement reaction, 2 ionic compounds just switch partners, okay, to create 2 different ionic compounds. All right, so if we're looking at our first reaction here, where we have nitrogen reacting with hydrogen to form a single compound, what kind of reaction would I be looking at there? That's a synthesis reaction. All right, so the first thing we would write there, okay, synthesis. Okay, now it also wants it to be written out in words. So if you recall, remember I said being able to write the names of compounds and write their formulas is like super important because it's a basic skill. Here's where it comes into play. All right, if I'm going to write this reaction out in words, I've got to be able to do that. Now, this is still just nitrogen. Does the fact that there's a 2 beside it change how I write it? No. This is one of our molecular elements. That means that there are some elements on the periodic table that like themselves so much that they bond to themselves. Okay? And they come as either 2s or 4s or 8s. Most of them are 2s. Okay? But the exceptions, the 4 and the 8, are phosphorus and sulfur. And phosphorus comes as a 4 and sulfur comes as an 8 when they are by themselves only. Okay? So I would simply write that in this reaction, nitrogen, that's supposed to be an E, is reacting with hydrogen. So I just have to put plus. Okay, I don't have to like write out a sentence or anything like that. Nitrogen plus hydrogen is going to give this stuff. Now, the compound it makes, ionic or molecular? It's molecular. Okay, nitrogen is listed before hydrogen, which means hydrogen is behaving as a nonmetal in this case. So we have a molecular compound. This would be nitrogen trihydride. Okay. It's also known as ammonia. Its common name is ammonia. If you've ever used Windex, glass cleaner of any kind, the smell is ammonia. Okay, that very kind of distinctive smell that glass cleaner has. Okay, that is caused by ammonia. That's what it smells like. Okay, now I need to balance this reaction. Since it's not a combustion reaction, I should start with the largest number. Okay, what's the biggest number in that reaction? 3. Okay, and it belongs to the hydrogens. So on this side, there are 3 hydrogens, and on this side, there are only 2. And I got to make it so that there's the same number on both sides. So what's the lowest common multiple of 2 and 3? 6. All right, so if I can make 6 on each side, it'll be balanced. All right, so I'm going to put a 3 here because 3 times 2 is 6. And I'm going to put a 2 here because 2 times 3 is 6. Everyone all right with that? When I do that, does that fix the fact that my nitrogens weren't balanced? It does, because now this 2 doesn't just apply to the hydrogen, it also applies to the nitrogen. And there's 2 over here. So now it's balanced. Okay, now it's good. All right, so as a general rule, if it's not a combustion reaction, we start by balancing the largest number. That's going to work like 96, 97% of the time. You're going to get the odd reaction where it doesn't, and you'll have to just start with something else. Okay? And I'll show you when that happens, exactly what to do, okay? And it'll work out. All right, how many people were able to get the second one done? Okay, let's look at the second one, and then I'm going to give you some time to get ahead of me on the others. Okay, so in the second reaction, I have nitrogen acting as an element here, reacting with calcium chloride, which is what kind of a compound? It's ionic. Okay, so I have an element reacting with an ionic compound, and it's forming another ionic compound and a different element. So what kind of reaction am I looking at there? That's a single replacement reaction. Okay, so I would write beside this, single replacement reaction. Okay, and now I've got to write it out in words. So this is nitrogen acting as an element, so I just write it as nitrogen. Okay, this is an ionic compound, so I write the name of the metal, and then the name of the nonmetal, ending in "ide." And then same with this one. Name of the metal, name of the nonmetal, ending in "ide," plus this element. What would I call this? Let's see how. Yeah, it's, well, chlorine, right? Because now it's an element, so I don't need to put the IDE ending. So it's just going to be chlorine. Okay. So I need to balance this. What should I start with? The largest number, which belongs to? Calcium. Yeah. Okay. So I've got 3 calciums on the product side, but I only have 1 calcium over here on the reactant side. So since I can't just put a 3 here, that would mess things up. What do I need to write right here in front of calcium chloride? What times 1 is 3? 3, yeah. Okay? Because remember, when I write this number, it's called the coefficient. It means multiply everything behind me by me. Okay? So now I have 3 calciums on both sides. Okay? This 3 also applies to the chlorine. So now I'm going to balance the chlorine. 3 times 2 is 6. What do I need to put here? Also a 3, right? To make 6. I need to have 6. Yeah. So I'm going to put it, because the 3 will go 3 times 2 equals 6. All right, when I do that, that balances my chlorines. Then I need to check my nitrogens. There's 2 over here and there's 2 over here. Well, that was good. Okay, now I'm done. Now the reaction is balanced. Okay, so that's what you do. You just kind of hop back and forth from reactants to products until you have everything set up. Okay, what I generally do is if I'm balancing part of a compound, when I write that number, I immediately go to the other part of that compound to check that it's balanced on the other side. Okay, and like I say, just hop back and forth. Okay, and do one element at a time. Trying to do any more than that can get really overwhelming. All right, I'm going to give you guys a couple minutes to get ahead of me, okay, on the third and fourth ones, and then we'll look at those together, and I'll give you a little bit of time to try the last 3 there. Okay, let's have a look at the next 2 here. So in the next one, I've got a compound that contains carbon and hydrogen reacting with oxygen. So the carbon and hydrogen containing compound is not ionic because carbon is a nonmetal. Okay? So that means that this can't be a single replacement reaction. It has to be what kind of reaction? Requires oxygen for these reactions, and they always produce carbon dioxide and water? Combustion. That's a combustion reaction. Okay, if you see H2O and CO2 as the products, it's a combustion reaction. It's really the only kind of reaction that's going to do that. So it's a combustion reaction, so we'll write combust. And I need to write it out in words. So, all right, since this is a molecular compound, I'm just going to write carbon tetrahydride. Okay, more commonly known as methane. It's the gas that's in farts. True story. Okay, and it's reacting with O2, which is oxygen. And that's going to react with water. And guys, when you see H2O or HOH, you can just write water. Okay, I don't expect that you write a technical name for water. Water is the one thing you can use a common name for. Okay, so it's just water. All right. Plus carbon dioxide. Okay, so combustion reactions have special balancing rules. Right? I'm supposed to balance them in alphabetical order, and if necessary, apply the rule of 2. Okay? I only use the rule of 2 if there are an even number of carbon atoms in the first compound. Is 1 even or odd? It's odd, and the loneliest number. Okay? So, we got 1, so we're not going to apply the rule of 2, so I'm just going to start balancing, starting with C, because it's the first one in the alphabet. Okay, well, it's not the first letter, but it's the first one in this compound in the alphabet. Okay, so we got 1 carbon, and on this side we have 1 carbon. That's easy. Okay, that one's already done. Okay, how many hydrogens here? 4. How many here? What do I need to multiply this by? All right, so I put a big fat 2 in front of that. All right, now that I do that, now I can figure out how many oxygens go over here on the reactant side, because I can see how many there are here on the product side. But I have to keep in mind there's oxygen in both compounds. And when I balance, I'm making the reactants and the products equal. Okay, so there are how many oxygens here?
2.
How many here?
2.
Also 2, because the 2 applies to this. So 2 times 1 is 2, plus 2 is 4. What needs to go here?
2.
A 2. I'm going to get 4. I'm going to have 4 in total, but 2 times 2 will give me that. Okay? Everybody with me on that? That's why we have to balance in alphabetical order. If we try and balance oxygen earlier, we won't be able to, because we won't know how many there are on the product side of the reaction until we balance the carbon and the hydrogen. So that's why we have that rule in place. Okay? All right. Next one. I've got a single compound, and it's breaking down into 2 elements. What kind of reaction would that be? That is a simple decomposition reaction. So I usually just write SD for those. You could write decomp if you want, that's fine too. All right, so I got to write it out in words. Ionic or molecular? It's molecular, they're both non-metals, so I'm going to need prefixes here. So trinitrogen, okay, disulfide is going to break down into nitrogen and sulfur. All right, is it all right that I didn't put a prefix in front of either one of those? Yep, because those are elements. Elements don't need prefixes. Okay, those are just 2 special elements that happen to come that way. Okay, I got a balance starting with the. Which one should I start with?
The biggest number.
Biggest number, which is sulfur. There's 8 over here. Whenever sulfur is involved, you're going to have big numbers, and you're going to have to do some multiplication. All right, so I got 8 sulfurs over there, and I got 2 on this side. So what's the lowest common multiple of 8 and 2? Yeah, or 8, right? I could include 8 in that. 8 times 1 would also be 8, right? So I got to get 8 over here, so what needs to go here? A 4. Yeah, 4 times 2 is 8. All right, what's 4 times 3? 12. All right, what times 2 is 12? 6. All right, so yeah, you got to do a little bit of your times tables. okay, to do the balancing stuff, but there's nothing terribly difficult. Okay, now that reaction is balanced. 12 nitrogens and 8 sulfurs on both sides. Okay, we don't have to write ones unless it's a fill-in-the-blank question. Okay, so if I give you a whole reaction and all you're supposed to do is balance it, and there's blanks in front of everything, put a 1 in the blank. Okay, because otherwise I don't know whether you knew it was a 1 or you just didn't finish the question. Okay, so if it's a fill-in-the-blank, fill in the blanks. If it's just like this, we know that nothing there means a 1. Okay, let's have you do the last 3. Okay, I'll let you get ahead of me, and then we'll look at how we go from word reactions to formulas, which is more intense. Not more difficult, it's the same thing, there's just more to do. So for our next one, we've got ionic compound, reacts with ionic compound, forms 2 different ionic compounds. What are we looking at for a reaction type? What do we think? There's only one type that has all ionic compounds in it.
Double replacement.
Double replacement, yeah. Okay, so we write DR beside that one. Okay, then we got to write it out in words. Since we know they're all ionic, we just use all the ionic naming rules here. So this would be calcium chloride. Reacting with sodium carbonate. Okay, that's going to give us calcium carbonate. And sodium chloride. Okay, and what should I balance first? What's my biggest number? What's that? 3 is the biggest number, but when I look at what it's attached to, it's carbonate. How many carbonates are there here? Just 1. Okay, so while it is the biggest number, and that's the reason I put this on here, is because we have to address this kind of a trick. Okay, that's not the biggest number of units. Okay, there's 1 carbonate on each side. In fact, right now it's already balanced, so I don't need to do anything with it. The largest numbers I have are these 2s, a sodium and a chlorine. Okay, I can pick either one to start with. Okay, I'm going to pick the sodium just because it's attached to something with a bigger charge. All right, so I've got 2 sodiums here. How many on that side? Just 1. So what needs to go in front of sodium chloride? Okay. If I put a 2 in front of that, does that fix everything? Yeah, sometimes you just get lucky that way. Okay? Sometimes all a reaction needs is 1 number, and it works out. Okay, but we should still double check it. 2 sodiums, 2 sodiums. 2 chlorines, 2 chlorines, 1 calcium, 1 calcium, 1 carbonate, 1 carbonate. Yep, it's good. Okay. Okay, how many people have done the last one? Okay. In the last one, is this the easiest reaction you could ever get for balancing? Because it has no what? No little numbers. If there's no little numbers, what is everything in this reaction? A 1. Yeah, so it's really easy to balance them because you don't have anything to balance. Everything's 1 to 1. Okay, so when you never see any little numbers, all right, the balancing is done. We don't have to do anything else. All right, when we're writing out all the words, okay, I've got an ionic compound reacting with an ionic compound, so it's the same reaction type as the one above. It's another double replacement reaction. All right, so here, this is ionic because hydrogen's listed first, behaving as a metal. So hydrogen chloride. Okay, and it's reacting with potassium hydroxide. Okay, what's HOH? Water, yeah. Okay, now, sometimes people ask, well, Coderre, why didn't they write it as H2O? And the reason is that you can write it either way, but in this reaction, when it comes back to balancing, it's easier to figure out where the parts came from by writing it that way. If I write that as H2O, I might go looking for 2 hydrogens together somewhere when they're really not. Okay, so typically in replacement reactions, you write water as HOH because it's easier to track where the parts come from. In a combustion reaction, you'd definitely write it as H2O because it's easier to track where the parts come from. Okay? Either way is correct. All right, so we got water and then we got potassium chloride. Okay, and as we said, it's already balanced. All right, so you don't typically get as many of this type of reaction question as you do what we're about to look at. Okay, in this reaction, I've given you the formulas, right, and just asked you to write the names. A question like this would probably be worth 4 marks, maybe three, maybe 4. Okay, and that would be 1 for the reactants, 1 for the products, 1 to have it balanced correctly, and 1 for the reaction type. Okay. Sometimes I only make it out of 3, and I just give 1 mark for all of the names together, okay, rather than break it up into reactants and products. Okay. But it's a bit easier to get these ones right because you have the formulas, and you know I already dropped and swapped or put the right numbers in, and you didn't have to come up with them. It is more challenging if you get the word reaction and have to put in the formulas. Because if you don't get the formulas right, you won't get the balancing right. Okay, does that sort of make sense? Like if I forget to drop and swap a compound, I won't get the balancing to work. Which is also a sign you need to watch out for. If you have been going back and forth, and you can't get a reaction to balance, you probably dropped and swapped something incorrectly. Okay? Because usually that's what happens. If you can't get a reaction to balance, it's usually because you missed something in one of the formulas. All right, so let's have a look at what that looks like if we're going the other way. Okay. Oh, here we go. All right, so let's just try for right now 1 and 2. Okay, we'll do number 1 together and then you guys can try number 2. All right, so in this one, I get the word reaction. Okay, so I've got to write it out first in formula form. So magnesium and chlorine produce magnesium chloride. In math, what does and mean you're supposed to do? Add, right. So when they say magnesium and chlorine, okay, I do this. Now, here's where this gets tricky. When chlorine is by itself, what does it look like? It's one of the special elements. This is where you can make a mistake. If you don't remember which ones are the special elements, the molecular elements, okay, you might forget to put a 2 here, which means you won't get the reaction right because that's not right, and you won't get the balancing right. You might actually get the equation to work out, but it won't be right. Okay, and that's not what we want, because then suddenly 2 out of your 4 marks are gone. Okay, for just forgetting to make a 2 here. All right, so magnesium and chlorine produces magnesium chloride. Okay, so that's Mg with Cl. That's an ionic compound. This is a +2. This is a -1. Drop and swap. Do you see how much extra stuff there is when you start with the word reaction? Okay, I've got to make sure I got all the formulas right. Okay, now that I've got that, what kind of reaction am I looking at? It's a synthesis reaction. Okay, magnesium and chlorine are both elements. They're combining to form a single compound. All right, is there any good news here? It's already balanced. Okay, there's 1 magnesium, 1 magnesium, 2 chlorines, 2 chlorines. Done. Okay, we don't have to put in any numbers. Okay. All right, dihydrogen monoxide, I'll give you that one. Water. Okay, all right. Gives off hydrogen and oxygen. If I see the word gives off, that means it isn't reacting with anything. What do hydrogen and oxygen look like as elements? They're what?
Water.
No, I've already got it here as water. Now it's giving them off. It's becoming hydrogen and oxygen as separate entities. What do they look like? They're both,
And they both have the two.
they both have a 2 beside them. They're both molecular elements. Okay? It's all these are all the little details that we unfortunately just have to memorize. Okay? These are some of the elements that come as 2s. Okay, what kind of reaction is that?
Simple decomposition.
Simple decomposition. In fact, it was the example of a simple decomposition reaction you had in the lesson yesterday. Okay, so H2O gives H2 and O2, and now I need to balance it. My biggest number is 2, but hydrogen already looks balanced, so what should I start with? Oxygen, because it's the thing that isn't balanced, and it's going to throw the hydrogens off in a minute. There's 2 here, but there's only 1, so what needs to go in front of this? All right, now how many hydrogens do I have? 4. What times 2 is 4? 2. Now it's balanced. Okay, so there's a bit more thinking to do when you get the word reaction than when you get the formula reaction. Okay? All right. We're going to go and let's have you try the next 2 here. These are actually in your booklet. Okay, so if you've been writing them down, you don't have to. They're in the booklet. Let's have you try those 2. Okay, so in number 3, we've got aluminum. Aluminum is a metal. It's not one of our special elements, so we just write it like that. Okay, it's reacting with oxygen, which is one of our special elements that comes as a 2. Right, so our reactants would look like that, Al plus O2. Right. When they go together, they're going to form aluminum oxide. Now, what kind of compound forms with a metal and a non-metal? Ionic. So what do I have to do with this? Drop and swap it. So Al is a 3 plus, oxygen is a 2 minus, drop and swap. Okay? What kind of reaction is that? It's also a what? It's a synthesis reaction, yeah, same as the other ones. Okay? It's a synthesis reaction. Okay? All right. What should I balance first?
The 3 on the oxygen.
The 3 on the oxygens, yeah. Okay, so there's 3 oxygens in the products, there's 2 in the reactants. What's the lowest common multiple? 6. Okay, so what times 2 is 6? 3. What times 3 is 6? 2. All right, when I put this 2 here, that works out for my oxygens, but it gives me how many aluminum? 4. So what needs to go here? All right, and I'm done. All right, how many people are done number 4? Okay, I'll give you about another 30 seconds here to get number 4 done, then we'll have a look at it. And then we might say we're good. All right, so on number 4, we got phosphorus. What does phosphorus look like when it's by itself? It's a 4. Okay, and then we got oxygen. How does it look like when it's by itself? It's 2. Okay, it's going to produce phosphorus pentaoxide. So how many phosphorus and phosphorus pentaoxide? Just 1, right? No prefix on it, so it's just 1. Okay, and penta means how many? 5. All right, so that would be our product. Right, another synthesis reaction. 2 elements combining to form a single compound. But again, I've got to remember, if I'm going to balance this right, that P is a 4 by itself, O is a 2 by itself. Okay. What should I balance first? Well, this is one of those weird ones. It's one of the very few where balancing the biggest number doesn't work. Okay, 5 is the biggest number. But if I just go and start trying to balance the 5s, it may or may not work out. Okay, in this case, it will not work. Okay, because if I balance the oxygens, I go, okay, there's 5 here and there's 2 here. What's the lowest common multiple of 5 and 2? 10, right? So if I put a 5 here and a 2 here, that does not balance my phosphorus. So I have to start over. That happens, okay? And that's what you do. You look at it and you go, oh, that didn't work. All right, well, I'll start with something else, the next largest number. All right, so I go back and I do the 4 first. All right, so there's 4 phosphorus on this side. How many over here? 1. So what do I need to put in front of this? A 4. All right. Okay, what's 4 times 5? Okay, what times 2 will give me 20? 10. All right, now it works. Okay, now it bounces. But that's one of those very rare cases where I followed the rules and it didn't work. Okay, and it's okay. The rule is, if it didn't work, go to the next biggest number, and it'll probably work. Okay, it'd be like a fraction of 1% where that would be something that would fail afterwards. Okay, all right. We are going to spend quite a while on reactions, guys. So if you're, looking at it right now and feeling a little panicked, it's okay to be a little bit anxious about it, but don't be fearful. We're going to spend time on it. I'm going to beat you over the head with it a little bit every single day, okay, until we get it. All right? But we're not going to just like rush on and leave you behind. Okay? Tomorrow, we'll do some more reaction stuff, and we probably won't get to our lab until after the break. Okay? So that's kind of where we're headed here for the next few days. Okay? Thanks for being good for Mr. Van Herb yesterday. I appreciate that.